velocity transducer trainer kit SP8892 made by SPR Electronics. This is used to measure the angular velocity of this motor by this tachogenerator. This is the generator. This is reverse motor. When we give the mechanical force, it will generate the voltage. This voltage is calibrated to meter to indicate the RPM. We will show the result in terms of RPM. And here is trigger wheel. Here is trigger wheel. It has 12 teeth, and here is inside magnet to provide the signal to Hall's effect sensor. Here is Hall's effect sensor, and this is block for infrared sensor, which is in bottom size. This is inductive proxy sensor. When this not go near this switch, that indicate the light, and when out, light is off. And this pulse is given directly in this RPM indicator, and this RPM indicator data is our reference data. Okay, and I am going to, here is comparator. This comparator is used to pulsating data from Hall's effect sensor and an infrared sensor to better pure square wave. Here is, they can create some noise, but when we apply in this comparator, this will get noise free data. Here is LM331 based frequency to voltage converter. Okay, here is voltmeter. We need the output signal in terms of voltage, not in terms of frequency. When we revolve is faster and faster, it will generate fast pulse. Something like 60 RPM means it revolves per second one pulse, and this shows sensor create 12 pulse per minute, per second. And when we increase this frequency speed to 90 RPM, that will generate 18 hours signal. When we increase to 120 RPM, it will increase get 24 hour signal. When we increase it 180 RPM, it will create something 36 RPM hours pulse. This pulse is converted directly proportional to voltage, and this is this section is calibrating sections. Okay, by this way we will provide the output to our voltmeter. First we are going to experiment our tachogenerator. Okay, connect negative to negative. Okay, and positive to positive input signal. Be careful when this come inside, that is go in the shaft in this lock, and after that your power supply will be damaged due to high residual current of motor. So you have precaution. Do not get any obstacle in this trigger wheel. Okay, I am giving signal volt. This should be first in 0. Okay, and okay, I am taking it open. This is because this high load signal. Okay, I am providing this volt signal to voltmeter. Okay, first we have to calibrate it on 0 value by changing this knob direction. Okay, that means 0 RPM. This is rest conditions. It's very difficult. Okay, okay, and now I am applying to voltage to this motor, and I am increasing voltage, and it starts revolving now here. Okay, I am providing here. Okay, let's I begin from 80, 70, 80 RPM. There is 80 rpm, but it shows the 132. If it shows negative value, you can send the terminal of this meter. Okay, this is positive. There is no matter for you. I am changing this meter value in 80 now. Okay, there is 80, 81, 81, and now I increase the supply voltage to motor. Here is speed of motor is increased. It's about 102. There is 100. Sorry, there is some flickering due to my hand. I have to edit now. Okay, 103, 102. When I reduce it, what we see here, this near value. Now I am increasing here. There is this 124. It's near about 120. Okay. This 144. This shows 150. There is 163. This is 173. Okay, you have to check the linear data. Okay. If you want to calibrate higher range, you will get better reading. Okay, I am giving here is 180 revolution. I reduce to okay, correct point. Okay, that is near about 130, and I am going to reduce input signal to motor. Here it will show 141, it will show 140. Here is 130, something 118. Here is 1920. Here is 106. Also here is 106. By this way you complete the experiment for tachogenerator. Let's remove the power supply from here and pull down this voltmeter input power supply to 0 volt, and I am going to demonstrate for infrared sensor output. Okay, first I have to apply 5 volt signal VCC to infrared sensor. Now here it is, and after I will apply to ground. Here is infrared sensor is blink the lead. Okay, and I apply to output to input of comparator, or output of comparator to frequency to voltage converter, and frequency to voltage converter output to our input for calibrating unit amplifiers, and the output of meter is applied to voltmeter. Okay, at rest condition, here is our speed is 0. That's why you have to calibrate its 0 value now. Okay, this 0, and I applied the voltage in your motor input. Okay, be careful when this wire come here, that it lock your motor, and after that your power supply is damaged, device will be damaged. So I increase the input voltage to our motor, and here is our RPM is indicated 88 RPM. By this way we can calibrate to RPM to 88. Okay, I'm increasing the value of RPM. Okay, these are near equivalent. And increase RPM of motor. Wait, wait until this reading will be stable. Okay, here is 122, here is 120, 21. This near value, I am increasing its value now in 144. Okay, it's near about 144, 142. Okay, I am increasing it in 160. Here it is increasing, waiting about 10 seconds. It is stable, output is 157. By this way, you can do experiment in this device for measurement of RPM or angular velocity, everything. Yeah, okay. Please reduce your power supply and remove the terminal power supply. Okay, by this way you can complete your experiment. In case of Hall effect sensor, please shift your 5 volt to 5 volt, output to output, and ground to ground. Okay, here is Hall effect sensor start to blink and apply voltage to motor. Okay, here is your device is started. Here is your output is 106. Wait some time and calibrating 105. Okay, and increase your speed. Okay, I increase speed in about 124 as 32. That is output is 142. Okay, I increase the speed in 143, 58. There is speed is same. I increase its speed in 201. Wait some time for stable output. Okay, there is 202, 3. This near value. By this way, you complete your experiment in this device. Thank you.